I think people are, asking again and again regarding that, the YouTube video or whatever the video, recorded video.
Mm-hmm.
I think, it would be nice if you can clear that out to all of us in the, like I already understood, like, where I can find that, but maybe some people they still doesn't know where that video is and then how to access those videos.
To access the videos, recording videos, you have to save the link of our
Yeah,
YouTube unlisted videos.
yeah. Can we
You
still
have to
download that?
maintain a notepad like this. No, you
Can we
can't
also?
download.
We can download.
No, you will have lifetime messages of the link. Videos will be
Mm,
available. Like you can maintain a note. Day one, you can put the link here. Day two, you can put the link here.
mm,
Like that.
mm.
Yes. Let's begin now. So in the last class, we had seen the basic of networks. What is network? Types of communication, types of network, modes of communication, and today we are starting with the fundamental, that is OSI model. OSI and TCP/IP. TCP/IP are the backbone of networking. Backbone of networking, the most important topic in CCNA. To learn any advanced technologies also, for packet flow also, for network troubleshooting also. The OSI model and TCP/IP is the most important topic. Can anyone tell me why we come up with OSI model? Why behind OSI? Why behind OSI?
Why?
Yes, why we come up with OSI model?
Maybe
Um,
to standardize.
yeah,
Very good. Why?
yeah, to
Why
set
we
the
need to?
standard protocol.
Why we need to standardize?
Because in a network, there might be different vendors. For example, I can have a Fortinet, I can have a Cisco, I can have a Juniper. So if we have that standard protocol that works with it, maybe so it can communicate with that standard.
Very good. So to make communication between all the vendor devices, earlier before OSI model, like two different vendor was not able to communicate with each other. Reason, they had their own standard, their own protocols, right? Like the encryption. For an example, there are two PC and both has their own standard of communication, right? Standard means, for an example, the algorithm used by PC1 to encrypt the data and the algorithm used for encryption on PC number 2 are different. Both are different vendor devices. Let's say this one is Dell PC and this one is HP PC or Apple PC, Apple laptop. So if the both has their own process of communication, their own protocol for communication, then they cannot communicate. So we come up with OSI model to standardize it.
Standardized.
Yes. So what is OSI model? OSI model is nothing but a blueprint, a common standard that every company, every networking company who is manufacturing the hardware or software, they will design their hardware and software according to the common standard, according to the OSI model, right? It is like a blueprint. Now, OSI model tells how a PC is going to send the data and how a PC is going to receive the data. Means if a PC need to send the data, let's say there is one data on PC number 1 that I need to send to PC number 2, can I send it directly? Can I send it directly? Can I send this data directly from PC1 to PC2? If forget about the data, let's suppose you are here, your friend is somewhere and you need to send one letter to your friend. Can you send the letter directly? How you will send the letter? First you will write the letter. After that you will put the letter in envelope, and then on the envelope you have to put the address,
Name.
name,
Yeah.
write the source address, destination address. Then only letter can reach to correct destination. Am I right? Without envelope or address we cannot send letter. Similarly, if the PC1 has some data, it cannot send to PC2 directly. First, PC have to add some extra information, right? PC1 have to put this data in the envelope, and over the envelope they need to add the address. That hey, what is my address, the source address, and what is the destination address where I want to send it. Getting my point? So adding
Yeah.
Yeah.
extra information with the actual data is the function of your OSI model. All the extra informations. Function of my OSI model, right? So that's how we are saying OSI model is an reference model or like a blueprint which every company uses to send or receive the data on every networking devices, guys, whether it is PC, laptop, mobile devices, or routers, switches, firewall, load balancer, doesn't matter which device it is. Every device will has same mechanism to send and receive the data. Router is also going to send data like a PC only, right? Because both are following the OSI model. What is the difference between OSI model and TCP IP model? So OSI model is a theoretical model, reference model, and actual implementation is my TCP IP.
Okay.
Like here, PC need to add the IP address with data source IP 10.1.1.1, let's say destination IP 10.1.1.2, let's say source MAC address A, destination MAC address, let's say B. There will be port number. So these are the extra information which we need to add with data. And now between PC1 and PC2, we can have lots of networking devices. So those all devices will forward the traffic based on these extra information. For an example, what I am saying, let's suppose there is one router between PC1 and PC2. Will this router check your actual data? No. The actual data is for whom? For PC2. Correct? So router will not check the data. What router will check? Router will only check this header extra information with data. And on the basis of this extra information, router will forward the data to PC number 2. Router will receive the data from PC1 and it will forward the data to PC2 on the basis of this extra information. Your networking devices like router, switches, firewall will never check your actual data, what is inside the data. Only PC2 will check. Similar like your letter, right? There will be one postman in between you and your colleague, your friend, if you are going to send the letter. But the postman will only check the header, right? The envelope. Postman is not going to open your letter. So sender machine and receiver machine only knows about the data. And what we want that only the genuine user, authorized user should have the access of data. No one in between should be able to access the data. Even if someone has access the data, they should be not able to read it. Means data should be encrypted. If we are going to send something through network, then there are so many issues. Like what if someone else will read my data? What if someone will modify in the data? So these are the issues when we send data over network, and your OSI model is solving these all issues. Getting my point?
Yeah.
OSI model and TCP/IP model are solving these all 72 issues. Around 72 issues are there when we send anything over network, and OSI model will take care of these all the things. After that, see, in other word, we can also say OSI model is nothing but one kind of task that your machines are performing while sending or receiving the data. When machine is sending the data, they need to add extra information. When machine will receive the data, like when PC2 is going to receive the data, first PC2 have to remove this header, right? First they will remove this header, and then it will pick the actual data. So it is kind of task. Task is nothing but the adding extra information, encrypting the data, adding the hash value with data. These are what? Task. Adding or removing extra information. Then encryption, adding the hash value for integrity. You will learn it. So these are different tasks performed by my networking devices whenever they send or receive data. And now guys, we have divided these tasks into some part. Why we divide it into 7 part? Why we have 7 layers in OSI model? Why we divide anything? What is the logic behind dividing?
So that if there's any issue, we know where to look for the problem or to solve the issue. And yeah.
Guys, we divide anything to make it easy. If I'm going to give you
Simple.
one book of, let's say, 5,000 pages, 5,000 pages, if there is no chapter, there is no unit wise, nothing, no page number, can you read this book? Can anyone read this book? It will be very difficult, right?
Yeah.
So that's why what we are going to do to make it easy for those who are going to read this book is we will divide the book into units, into the chapters, to make it easy for those who are going to read it. Similarly, in the OSI model is performing lots of tasks, and to make it easy we divide it into 7 parts, so that people can learn it easily, people can understand it easily, and the most important thing, if there is any issue in the network, then you can identify the issue is at which part. It will help you in the troubleshooting. So that's why we are saying OSI model is very important for network troubleshooting. Network troubleshooting. Very important. May I know the name of each layer?
Yes. Um, we start from 701, layer 1,
Which one is the
physical.
7?
Application.
How?
The layer service application, that is the.
Application is a layer 1, I am saying. I am saying it is a layer 1. On the receiver machine, application
Oh, yeah, yeah.
is going to be layer 7. On sender machine, application layer is going to be layer 1. right?
Yes.
Here if I will talk on PC1, on PC1 application layer is the first layer. On PC number 2, if PC2 is the receiver, then physical layer is the layer 1. So
Okay.
application layer can be layer 1 also, it can be layer 7 also, depending on
Sender
device.
receiver.
Yes, sender or
Yeah.
receiver. Application, then presentation,
Presentation.
then
Session.
session, then
Transport.
transport, then
Network.
network,
Data link.
data link,
Physical.
and physical. These are 7 layers of OSI model. Application layer. What is application layer? What is the responsibility of application layer in the network?
It is an application like web, like the email or web, whatever application we are using. Our interaction point.
Yes, interaction point. Very good. The user interface. User
Yeah.
interface. Application layer. Through application layer, you are going to interact with application, user, and application interface, we can say. For an example, you need to send a mail to your friend. You need to send a mail to your friend. So you need one application like your Gmail, email. Those are what? Those are application. The one interface in between user and the actual mail server. If I need to access Google server, Google website, again what I need? I need one interface like a browser. That is
Yeah.
what?
The interface.
That is interface. This is interface called application. And who works on application layer? People who are designing the application, designing the interface, means software developers and software tester. Those guys works on the application layer, right? But on application layer, there are some networking protocols which you need to learn, like your
Yeah.
telnet,
HTTPS.
SSH, yes, HTTPS, FTP,
SMTP.
SNMT, SNMP, DHCP,
DNS.
SMTP.
DNS,
SMTP. SMTP.
BGP,
Is BGP application layer protocol?
yes.
Okay.
So these are the application layer protocol which you need to learn as a network engineer. But we don't need to learn how to design the application and those all things. That is not our task. If I will talk about the presentation layer, guys, so presentation layer is actually responsible for, see, it's clear with your name, present,
Yeah.
right?
Like compression,
Compression,
encryption.
compression and decompression, right? On the sender machine, you need to compress the data sometime. On receiver machine, we need to decompress the data. Now, why compression is required? To reduce the size. For an example, guys, you have one file and you want to send that file to your friend through WhatsApp. But you know, on the WhatsApp, there is a limit. Even on the mail, there is a limit that you can only send 10 MB file through WhatsApp. And if the length of file is 20 MB, then I can't send through WhatsApp or mail. In that case, we can convert the file into zip file, means that is nothing but the compression only. So first we can compress the file, then we can send our friend. The second task is, as I told you, encryption and decryption. These are the tasks of your presentation layer. Session layer,
So it will maybe start the session and end the session.
very good. It create session, like if I am going to type www.google.com in the browser, my machine is going to create one session. It should be not like this now, that whenever someone is requesting for the Google server, my machine will be waiting for reply for lifetime. If I am going to send any request to any server, to the Google server or any other server, there should be a timer. Until that time we need to wait for the response message. So that's why session is very important. And see, in the same browser there are multiple tab. WhatsApp is also there, Google Meet is also there, new tab is also there. So who is separating these all session? Session layer only. If there is no session layer, guys, WhatsApp reply can come in this tab, Google Meet reply can come in this tab, right? So whenever you are going to send any data to the any other machine, your session layer will create a session. So it creates session, maintain session, maintain session. For example, you are downloading a movie from the Google, length of movie is 2 GB, right? In that time your session layer will make sure that your session will not terminate until unless you have not completed the movie download. Maintain the session, and at the last when you will close the browser, then it will terminate the session as well. Session. But you know, these three layers are for software engineer. Software engineer works on these three layer of OSI model: application, presentation, and session. In TCP IP model, we are going to combine these all layers. In TCP IP model, we will have single layer, that is called application layer, and all the tasks will be performed by that layer only: the presentation layer task, session layer task, and application layer task. In TCP IP model, we don't have separate three layers for application. These are the tasks related to your applications. The actual work of network engineer begin from here, from the transport layer. And guys, transport layer, network layer, data link layer, and physical layer, these four are most important layers for network engineer. If you know the transport layer very well, you can troubleshoot the application related issue. Let's say if a customer is complaining that I am not able to access a particular site, particular application, in that case your transport layer will help you to troubleshoot the service, that oh, let me check service is running on the server or not, I'm able to access that service from all part of my network or not. Those are the tasks of your transport layer. So
So, excuse me for interrupting. I have a question.
go ahead.
Let's say for the session layer, and let's say we are trying to maintain, like, to connect the web server. If we're going to connect, like, we're going to browse on Google. Okay, so it is going to create a session, and but how, like, it has to make the session secure, isn't it? Like, to ensure that we are working on a secure connection, like TLS. But then
For all the
the
secure
encrypt.
protocol, first your machine is going to establish TLS connection.
Yeah, where does this happen? At which layer does this
SS,
happen?
transport layer. These are transport layer
Okay.
security.
Okay, so the encryption to ensure that before we start communicating, the secure connection is established. This happens at transport layer itself.
Yes, here, see, transport layer is going to decide whether the communication is going to be secure or unsecure. The communication is going to be reliable or unreliable, means there will be
Okay.
acknowledgement or not. Those all
Okay.
things will be managed by your transport layer. From here, the networking begin. Okay.
Okay. Thank you.
So transport layer is responsible for what? Reliable
Yeah. Connection. Delivery.
communication. Right? Your communication is going to be reliable or unreliable. Reliable means there will be acknowledgement. Like if I am sending something to my friend, there should be the acknowledgement, right? During the meeting class, you can see right now. I am asking you again and again, is it clear? And you guys are saying yes, yes, yes. That is what? That is acknowledgement. Am I right?
Yeah. Yeah.
So some communications are reliable, some are not reliable. If there is no acknowledgement, that means that is unreliable. Why we need unreliable or reliable? You will learn it very well, don't worry. Sometimes we need fast communication, doesn't matter it is reliable or not. The communication should be very fast. For an example, video conference. Google Meet, WhatsApp video call. These types of communication need fast data transfer without acknowledgement. If there will be acknowledgement, then communication is going to be slow. It will be irritating then. If I am
Yeah.
speaking something now and you are receiving it after 2 minutes, 1 minute, 30 seconds, 10 seconds, it will be very irritating, right? Yes. So my transport layer is going to decide whether communication is going to be reliable or unreliable or slow or fast, slow and fast, connection oriented or connection less. You will learn this as well, connection oriented or connection less. Let me talk more later about the transport layer. Now the network layer. What is the responsibility of network layer? No idea.
Sorry, what is your question? Sorry.
Responsibility of network layer in the OSI model.
I know IP works in network layer. So
Or the routing.
all the communication happen in the
Like I am
network
saying,
layer.
I am see how I have mentioned all the above layers. Like application layer provide the user interface, presentation layer is
Mm.
responsible for compression, decompression, encryption, decryption, session layer is responsible for
Oh.
creating session, maintaining session, transport layer is
Okay. Okay.
responsible for reliable communication. Similarly, network layer is responsible for what?
It usually determines the best route to reach the
That
destination.
is the function. Okay, fine. It is responsible for, guys, host to host communication. Data link layer is responsible for hope to hope communication.
Sorry, one question, sir, before we, complete that.
Hmm.
I want to go back to the transport layer.
Hmm.
Um, you said that in transport layer, reliable, unreliable communication, slow and fast communication.
Hmm.
So in that slow and fast communication, so for example, if my network is very slow, do I have to go and then check it in transport layer? Does
No,
it
no,
mean that?
no. It means that some applications are designed in such a way so that their data will travel without acknowledgement. Some
Hmm.
applications are designed in such a way that there will be no acknowledgement. Only data. The sender machine is sending, receiver machine is receiving. That's it. Sender machine
Yeah,
don't know receiver machine has received it or not.
yeah.
That is going to be fast communication. Some applications are designed for the acknowledgement that when sender machine will send anything and if receiver machine is received, then receiver machine
Hmm.
have to send acknowledgement, then only sender machine will send next data.
Okay,
Until
yep,
and unless sender machine will not receive the acknowledgement, it will not proceed with next data.
yep.
If your
So,
network is slow, the performance is poor. That is the issue of your network, not the application issue.
okay.
Okay, here I am talking about for the applications. Which applications? Like HTTP is secure. HTTP is not secure. HTTPS is secure. Telnet
Yeah.
is not secure. SSH is secure.
No, no, no. I'm talking with the transport layer about that fast and slow communication.
Yeah, I am telling about transport layer only, brother. On the application layer, whatever protocols are there, na Telnet, SSH, HTTPS, FTPS, NMP, DSCP, DNS. Some protocols are fast. Some protocols are reliable. Who will
Okay.
decide that? Your transport layer will decide that. Your transport layer only know that okay, if it is DNS packet, then I don't need to establish any connection. I need to
Oh,
send it
okay.
directly. It is like that.
Hmm.
We are not over the network. We are on the PC only. When we learn the
Mm.
OSI model, then we are here only on PC1 or PC2. We are not over the network.
Mm.
We'll talk about network later. Here network is not in picture now.
Okay.
One minute.
Yep.
Okay. Yeah.
1 minute. 1 minute. And the physical layer is nothing but the media. Media between devices, right? It can be wired or wireless
Less.
media. In the last class, I had told you the components of network, like there should be sender, receiver, media, protocol, and data. Am I right? So that media is physical layer. And as a network engineer, you are going to work on these four layer. There can be issue on transport layer in the network. There can be issue on network layer. There can be issue on data link layer or issue with the media, with the physical cable. Sometimes we need to replace the cable, we need to replace the port, we need to replace the
Mm.
connector, those all things.
What is that hop to hop communication
Hop
mean,
to hop
sir?
communication means see here I have one PC,
Mm-hmm.
some routers are there,
Mm-hmm.
layer 3 device 2, and again there is another PC2. So PC1 and PC2 are there, and between PC1 and PC2 there are two hop router. There are two network layer device routers are there. So hop to hop communication means communication between PC2 to router 1, communication between router 1 to router 2, communication between router 2 to PC2. Getting my point? This is called
Mm-hmm.
hop to hop communication. When PC1 need to send something to PC2, PC1, PC2. If PC1 need to send something to PC2, what will happen? At Data link layer at layer 2, hop to hop communication. What I told you, hop to hop communication. So at layer 2, PC1 will forward data to whom? To router 1. At layer 2, PC2 will send data to whom? To router 2. That is their gateway, default gateway. PC2 will send it to router 2 will send it to PC2. This is layer 2. At layer 2, communication is going to be like this, right? If you will ask me, Praful, what will be the destination MAC address? If PC1 is sending something to PC2, the destination MAC will be the MAC address of router 1. On the router 1, destination MAC will be router 2. On router 2, destination MAC will be PC2. But if you will ask me about the destination IP address, so destination IP address will be PC2
PC2.
directly on PC1.
But
right?
source IP address will change, isn't it?
No. Source IP, let's say 10.1.1.1. Destination IP, let's say 20.1.1.1. Right? MAC address is, let's say, for an example, here A. MAC address over here is, let's say, B. MAC address
So
over here
why,
is,
like, if it when that packet reached to router one, the source address will be the router one address, isn't it? Will it not to be that?
wait, I am telling you, E, F. These are the MAC addresses.
Okay.
Clear? Now, if PC1 need to send anything to PC2, source IP will be what? 10.1.1.1. Or I am saying
Yep.
10.1. Destination IP will be what? 20.1. Source MAC
Yep.
will be A and destination MAC will be what? C.
See. Yep.
Got it? It will
Yep.
forward to router 1. Router 1 router 1 is going to change layer 2 information. Source MAC will become what here? D, and destination MAC will become what? E.
E.
When PC router 2 will forward it to PC2, source MAC will become F and destination MAC will become what? B.
B.
So see, source IP and destination IP are exactly same on every device, but layer 2 information is changing at every hop.
Even in layer 3 communication, the source and destination IP
It doesn't matter what is
will
the
not.
data, application layer or the transport layer or network layer. Doesn't matter. I am not talking about the upper layer, right? Apart from the network layer and data link layer, there will be layer 4 also, transport layer also. There will be port number. Let's say source port number is 1025, destination port number is 443. And let's say application layer, at application layer we have the actual data. That is my data. Actual data. Let's say HTTP request as request. So routers don't know about the actual data. What is the actual data? What is the inside the data transport layer information? Routers will not check these all things. Router will be forwarding traffic based on your these two header. Right? So transport layer is service to service communication. Service to service communication. See, I am accessing which service, which protocol? 443. That means HTTPS. Network layer is host to host communication, PC1 to
Your
PC2
voice is
IP.
very, it's choking. I don't know. Maybe you're very far from your microphone or something like that.
No, I am very near.
Okay.
Is it for
Now,
Yes.
now,
everyone?
Now it's good.
Okay.
Yeah, so can we say that here? So there are two hops. That is from between PC1 and PC2.
Yes, there are two hop between PC1 and PC2.
Okay.
hmm, hop.
Yeah,
Can we say
clear.
hop as a router?
Yeah, you can say hop as a router, firewall, or any layer 3 device. It can be
Okay.
MLS.
Okay. So hop is a layer 3 device.
Yes. Layer 3 device who has capability to change the layer 2 information. See, at every router, layer 2 information is changing, right? The device who has capability to change layer 2 information are called hop.
Hmm.
And the device who will change layer 2 information will also decrement in TTL by 1. Now you can ask Praphul, what is TTL? So I am not adding multiple things, guys, here at the same time.
It will be confusing because I think these are the things that we may have to discuss down the line
Yeah,
if we just
exactly,
mix up
exactly. There are so many
all
things.
Yeah,
together.
yeah,
Yeah, now so
There are
it will
so many
become so
things,
much
and at the
confusing.
end, everything will be connected. Don't worry. Okay.
Okay,
For now,
so
see here. Transport
let's
layer is service to service communication. Network layer is providing host to host communication, and data link layer is responsible for
hop to
hop to
hop.
hop communication. Right? And from here your networking begin. Now I will talk about these all layers in detail: transport layer, network layer, and data link layer. Let's start with transport layer. Transport layer. First of all, guys, before transport layer, one more thing. Let me delete it. Yeah. Let's suppose there is one PC and one server. Let's say Google server. PC and Google server. In between, so many networking devices can be there, or for an example, both are directly connected. Doesn't matter. Let's say this is my PC one and this one is server. Server. PC IP address is 10.1.1.1. Server IP address is 10.1.1.2. PC MAC address is A and the server MAC address is B. Clear? And this is Ethernet cable. Ethernet cable. For the LAN, Ethernet is the technology which we are using nowadays to connecting devices in LAN, in local area network. Ethernet. Now, try to understand the OSI model here. If I'm going to open the browser on PC and going to type www.google.com, what will happen? You all know that PC only understand bits 0101, right?
yeah.
Google PC don't know what is google.com. So PC will convert it into bits, and then PC is going to resolve the IP address of google.com. See, if PC need to send something, if I am going to type www.google.com, PC can only understand one thing, that user is trying to access the web page. Right? Automatically here it will add, your system will add the protocol HTTP as like this. Correct? Now this is the URL. This is the URL. Now your PC know that, okay, I need to use HTTPS protocol. That means someone is trying to access the website. To access the website, there are two protocols, HTTP and HTTPS. Here PC is using HTTPS. Now your PC need to send request to the server, Google server, that hey, I need your web page. And if PC need to send the request to the server, PC need IP address of server. Am I right?
Yeah.
Where
Yeah.
is the IP address?
So IP address of that www.google.com.
Yes, IP address of www.google.com. Where is that?
So it is saved somewhere in the server.
PC
It
is
is
going
a
to look up their
conversion.
cache memory to find the IP
Yeah.
address of google.com. If it will not find the IP address of google.com in the cache memory, it is going to look up for the DNS server IP address. Hey, is DNS server IP address configured? If I know the DNS server, then I will ask to DNS server. Then PC is going to ask to DNS server, hey DNS, do you know the IP address of google.com? Please tell me the IP address, I need to send something.
Mm.
I will
Yeah.
talk about the DNS as well. Okay, in the packet flow, I will definitely include the DNS. For now, for an example, the PC has resolved the IP address of www.google.com, which is 10.1.1.2, somehow
Yeah.
through the DNS. Later we'll see the DNS flow as well. Now this PC need to send the request, HTTP as request message to whom? To www.google.com means 10.1.1.2. This is application layer. Who has generated the request, guys? Your application layer. You don't need to think about the presentation layer and session layer here. How presentation layer is going to encrypt it and how session layer is going to create the session. Now you can think application layer will directly forward this request to transport layer. Even in TCP IP model, there is application layer,
Transport layer.
application, and then transport. Right? So now who is going to receive the data? My transport layer. Who is going to receive the data? My transport layer. Data is what? Data is HTTP request, HTTPS request. Now data is a transport layer. You know, at transport layer there are two protocols running. Two protocols are running on transport layer. One is TCP
TCP and UDP.
and another one is UDP. So either transport layer protocol will use TCP protocol or UDP protocol for all the application layer data. Whatever data transport layer is going to receive from upper layer, from the application layer, it will either use TCP or
UDP.
UDP. So as a network engineer, here you have to remember some application layer protocols which uses TCP and UDP. Like you should have knowledge that okay, HTTPS uses TCP, DHCP uses UDP, like this. As a network engineer, you should have knowledge about this. Which protocols are TCP based, which protocols are
UDP.
UDP based, right? And you know what I told you, transport layer is going to decide whether your communication is reliable or unreliable. So
Unreliable.
actually TCP protocol is reliable and UDP
Reliable.
protocol is unreliable.
Unreliable.
What I told you, transport layer will decide the communication is fast or slow. TCP is slow and UDP is
Fast.
fast, right? So here we need to learn the difference between TCP and UDP first to learn the transport layer in better way. So this side I am going to write the TCP and this side I am going to write the UDP. TCP and UDP. You have seen this topic in your CCNA 200301 version 1.1 syllabus as well. Am I right?
Yeah.
Most important topic of CCNA. See.
Sir,
Yeah.
I'm sorry to interrupt. Now it's time for me to go because I need to drop my daughter to her dancing class. So I might have to view the recorded lecture. I'm sorry about that. Next time, tomorrow I'll join it. Is that okay, sir?
Yeah, it's okay.
Yeah. All right, sir. And then I'll make that remaining payment as you have mentioned. Thank you.
Okay.
Thank you.
TCP stands for transmission control protocol.
Protocol.
Transmission control protocol, and UDP stands for
User datagram protocol.
user
Datagram.
datagram protocol. TCP is reliable, or before reliable let me say TCP is connection oriented protocol, and UDP is
Connectionless.
UDP is connectionless protocol. Connectionless protocol. Now, the very important topic. What do you mean by connection oriented and connectionless? Connection oriented means before sending any TCP message, your sender machine and receiver machine will establish one logical connection. What I am saying, sender machine and receiver machine will establish a logical connection. Question, how, Praful? With the help of TCP header. Question, what is header? Header is nothing but the extra information, like your envelope. Your envelope is what? One kind of header.
Yeah.
Envelope is one kind of header, that is extra information. Why we need that extra information? To send packet to the correct destination.
Mm-hmm.
Right? So with the help of TCP header, all the TCP protocol will establish the connection. For an example, again here is one PC and one server. PC and server. Now when transport layer is going to receive the data, source IP 10.1.1.1, destination IP 10.1.1.2, and guys, you are going to configure this server as a web server, application server, am I right? So
Yeah.
once we configure this server as application server, automatically port number 443 will enable here, or port number 80 will be enabled. Very good.
Yeah.
Now your PC, at PC, transport layer is going to receive the actual HTTP request. Again I am on same point, request, and your transport layer is going to check which protocol it is. This protocol, the traffic which I am receiving from the application layer, is TCP based or UDP based. If it is TCP based, then I cannot send this data directly to the server. What it will do? This HTTPS is TCP based protocol. It will put it on hold. It will put it on hold. And it is going to generate one new message, that is called SYN message. Now question, what is SYN message? SYN message is nothing but the TCP header with SYN bit on. This is TCP header with SYN bit on. SYN stands for synchronization. Synchronization bit is on in your TCP header. What is the use of SYN message? It is used to establish the connection, logical connection,
Yeah.
between source and destination. In the SYN message, what will be the information? In the SYN message, there will be source port number and destination port number. What will be the source port number? Source port number will be the random port number. Right? We will talk about port number as well. There are two types of port number, guys: random port number or free port number, and well-known port number.
Sir, sorry, your voice is choking, like you are a bit far from the mic.
No, I am very close to the mic.
Yeah, sometimes I'm just losing.
Okay. So here source port number will be the random port number. Why source port number will be the random port number? Because guys, source can be anything, right? It can be my PC, it can be your PC, it can be Google browser, it can be Opera browser. Source is not fixed. But the destination, you can see destination is fixed, that every time whenever you need to access HTTPS server, then you have to send the request on 443 or port number 80. Am I right? Destination is well known here, well defined. but source is random, unknown.
Random.
So that's why source port number will be random. Let's say 1025, and we'll talk about the port numbers. What is the range of random port number and well-known port number? And destination port number will be 443 well-known port number. After that, here network layer will add source IP and destination IP. Network layer is going to add source IP, destination IP 10.1 and destination IP 10.2. And then data link layer will add source MAC and destination MAC. Let's say source MAC A and destination MAC B. This is my SYN message. And now the PC will send this SYN message to server. Server will first check layer 2 information, destination MAC. If destination MAC will match, then it will accept. It will check layer 3 information, destination IP address. If destination IP will also match, it will accept. Then it will check destination port number. If destination port number is enabled on the server, then it will accept and check the TCP message. In the TCP message, guys, SYN bit is on. Server will understand that someone is trying to establish the connection. Someone is trying to establish the connection. So in similar way, your server will generate SYN plus ACK message.
Acknowledgement.
Yes. SYN plus ACK. SYN message, it is sending their own SYN message because server is also trying to establish the connection, and acknowledgement for the received SYN message. Server is giving acknowledgement to PC that, hey brother, I have received your SYN.
Yeah.
And then finally my PC is going to send the acknowledgement.
Response. Yeah.
Yes, acknowledgement. And now after these three messages, we will have the TCP connection here between source and destination. What it is? It is TCP. And now the actual message which was on hold, that the actual HTTP request will be sent over this TCP connection, right? So all the TCP based communication will happen through this
SYN
connection, through this TCP connection. In case of UDP, there will be no any connection.
Yeah, connectionless it is.
Yes. PC1 and server. Do you know by default is there any protocol enabled on router? Is there any protocol enabled by default on the router, guys?
I don't know.
By default, one port number is running on the router, that is port number 23. Port number 23 is telnet. Port number 23 is telnet. You can check it. Here I have access of my server and PC. On the PC or on the server, on any device, you can check the port number. So control plain host open port. See which port number is enabled by default. TCP port
23.
number 23 for telnet. This server is only listening on one port number. If I am going to enable HTTP protocol here, IP HTTP server, and now now see how many port numbers are enabled.
80 and 23.
80 for HTTP and 23 for telnet. Similarly, if I will enable
Telnet.
HTTPS protocol also, IP HTTP secure server. Now how many port numbers are enabled?
4.
4 port numbers.
22.
22 for SSH, 23 for telnet, 80 for HTTP, and 443 for HTTPS. So now this server is listening on these all port number. If I will enable the DNS service, now see 53 port number is also enabled, right? Which is
Yeah.
for the DNS, right? If I am going to enable DHCP, see now 67 port number is also enabled, right, for DHCP. So this server is listening on these all port numbers. Some are TCP based, some are UDP based. You can see DNS and DHCP are UDP based, and these all are
Yes.
TCP based. So if I am going to send any UDP based traffic from PC1, then guys there will be no any connection, right? It will directly send the data. If I am going to send any DNS or DHCP data from PC1 to server, it will not establish TCP connection. But if I am going to send any TCP based traffic, it will first establish connection. Right now here you can see so TCP brief. This is the command to check TCP connection. Is there any TCP connection? No.
No.
Right? Let me configure the IP address interface F0/0 no shutdown, and here I am configuring IP address 10.1.1.2.255.255.255.0 for an example, and on PC1 config T interface F0/0 no shutdown, and IP address 10.1.1 255.255.255.0.
So we learn all these commands. It appears to be so complicated.
Sorry?
We learn all these commands.
Yeah, you will learn these all commands. So we don't have any TCP connection, but guys, if I am going to send any HTTP traffic from PC1, then it will establish the TCP connection. For an example, telnet and 10.1.1.2. Telnet uses TCP protocol, and you can see the connection. Forget about the state. State is not established now, but it tried to establish a connection. Who? 10.1.1.1 with what port number? With random port number, this one. Destination 10.2 with port number 23. If I am going to configure the telnet, forget about the command for now.
Yeah.
Password Cisco, and let me say login. and enable password is also Cisco. And go to PC1 and now try to access server. Now it is asking for password. Password is Cisco. And now on the server, if you will check TCP connection, you can see here state is
Established.
established. Right now, all the telnet traffic will go through this connection only. This is the meaning of reliable. Reliable means, sorry, not reliable, connection oriented. All the TCP based protocols are going to first establish connection before sending the actual data. This particular thing is called connection oriented,
Oriented.
right? And UDP, you know, UDP is connectionless, right? After this, the actual HTTP request will go.
So there won't be that part of sins in act in UDP then.
In the UDP, there will be port number. See, here I have again PC and server. PC IP address again 10.1.1.1. Server IP address is 10.1.1.2. Which server it is? For example, DHCP or DNS.
Mm-hmm.
Right? So again, your application layer is going to generate DNS query message. If my PC need to resolve, let's say www.google.com, so it will generate DNS request or DNS query, you can say query, DNS query message. Who is generating DNS query message? Application layer. Application layer will send it to transport layer, and this time transport layer is going to use what? UDP protocol,
Yeah.
right? So transport layer is going to add source port number, again random port number, destination
Yeah.
port number, DNS port number 53, source
Mm-hmm.
IP 10.1, destination IP 10.2, source MAC address A, destination MAC address B. But this time here transport layer is not going to create any connection. It will directly send it to server, DNS server without TCP connection. Getting my point?
Uh, yeah, so the 1025 is a random port, right? Which is sending.
Yes.
The 53 is a destination. So how you got this 53? It is the port is a port.
53 port number are the well-known defined port number. Defined port number means the port number which we have already assigned to the protocol. No one else can use this port number 53. It is already used for DNS server. So see again, to
Okay.
resolve domain name, source can be anything. It can be my browser, it can be your browser, right? Multiple people are there in the network, but there is only
Mhm.
one DNS server. So DNS server is well known. We all
Okay.
know that if I need to resolve domain name, then I have to go to port number 53. But source can
Okay.
be you also, source
Any.
can be my laptop also. So source is not defined, right?
Yeah, yeah.
So that's why source port number will be the random port number. Source can be anything.
Yeah, okay, yeah. No, I was asking for the destination port mean, yeah. So it is always 53 because
Yes.
it is
For the
already
DNS,
defined.
it will be always 53.
Okay. Like for telnet it is 23.
Yeah. For telnet 23. Right? Now, all the connection oriented. See, guys, definitely this TCP is going to be slow than UDP, right?
Yeah.
TCP will be slow than UDP.
Yeah.
There is one extra process before sending the actual data. Now, next thing is whatever data will send over this TCP connection, there must be one acknowledgement. There must be one
Yeah.
acknowledgement. Acknowledgement. But in case of UDP, there is no acknowledgement.
Yeah.
Right? So if I am going to send now actual HTTP request to the server, server will give acknowledgement that okay brother, I have received your first request. How it will track? We'll learn those all things. There will be sequencing, guys. Sequencing,
Yes.
acknowledgement. We need to learn those all things.
Mhm.
How it can track the acknowledgement. But there will be acknowledgement mechanism in TCP based communication. There is no any acknowledgement in case of UDP.
Yeah.
Right? So that's why we are saying TCP is an reliable protocol. Reliable means there is acknowledgement. If there is acknowledgement, we can say it is reliable. If there is no acknowledgement, we will say this is unreliable.
Unreliable.
Unreliable. So one protocol is reliable, one is not reliable,
Unreliable.
unreliable. Right? In other words, we can also say this one is slow protocol and this one is fast protocol.
Yes.
These are the basic differences between TCP UDP. You can also add sequencing or three-way
Yeah.
handshake.
Hmm.
The SYN plus ACK, and ACK is nothing but the three-way handshake.
Yeah.
But there is no three-way handshake in case of UDP.
UDP.
Right? Segmentation. Segmentation can be done in TCP, but segmentation is not possible in case of UDP.
So what is this segmentation?
Hmm?
What is segmentation?
Segmentation is the process of dividing large size of data into a smaller part of data. Division of data. Why?
We, yeah.
Let me tell you. For an example, this is the PC. There is one router. And then we have server here. You know MTU, what is MTU? Maximum transfer
No.
unit.
Okay.
MTU is maximum
Maximum transfer.
transfer unit. MTU.
Okay.
Transfer unit means the maximum size of data that can be transferred from the interface. This one
Yeah.
is R1. PC, if PC is sending any data to the server, router is going to receive it on this interface, let's say 0/0 interface, and it will forward from 0/1 interface, this interface.
Yeah.
Done. For an example, MTU of this interface faster than 0/1 is 1500 bytes.
Okay.
MTU is 1500 bytes means router can send up to 1500 bytes of data from F0/1 interface. Am I right?
Yes.
It can only send up to 1500 bytes of data from 0/1 interface. Now let's say length of data is 3000 bytes.
Mm-hmm.
Length of data is 3000 bytes.
Yeah, it will
User
segment.
don't know about the router, right? Now, if
Yeah.
user will directly forward it to router, what will happen? Router will discard this traffic, drop the traffic. Am I right?
Yes.
Because the length of data is more than their MTU size. Router
Yeah.
cannot forward it.
Mm-hmm.
In this case, if you have the TCP protocol, if the
Okay.
communication is going to happen over TCP, if there is TCP connection, then your PC have already knowledge about the MTU. That what is the MTU, minimum MTU between source and destination. According to that, your PC is going to divide the data. The minimum MTU is 1500. So data will be divided into two parts. Getting my point?
Yeah.
That is called segmentation. So segmentation is only possible in case of TCP. Why? Because while three-way handshake, it will also measure the minimum MTU. In the UDP, there is no three-way handshake, right? PC don't know about the minimum MTU between source and destination.
Yes.
So for the UDP, router have to divide the data. In that is called fragmentation. We have to configure that. In my scenario,
Okay.
see, if I am going to ping from the PC1, if I am going to ping 10.1.1.2, ping is working. Ping is working.
Yes.
If I am defining the size of ping, 2000 bytes, and I'm turning off the fragmentation bit. I said don't fragment. Now you can see ping
Okay.
is not working. Why ping is not working? Because ping is not the TCP based protocol. It's a network layer protocol, ICMP. And the size of data is more than MTU size. But if I will remove this don't fragment bit, then ping will work. You can see then ping is working.
Yeah.
That means router is performing fragmentation. Don't worry, we will
Okay.
learn these all things.
Yes. Okay.
TCP and UDP, is differences clear?
Yes, sir. It's clear. Yeah.
1 minute. Just give me 1 minute, please.
Yeah, sure. No problem.
Yeah. Can we continue?
Yes, sir.
Great. So transport layer will decide the communication is going to be TCP based or UDP based. If it is TCP based, then before sending the actual data, it will establish the TCP connection. If it is UDP based, then it will directly forward the data. And if it is UDP based, then there will be no any acknowledgement.
Yeah.
Right? Even you can see this by capturing the link. What I can do here, I can clear it and see now TCP brief. Now there is again no any connection. I can capture this link to show you the data. Capture. Through Wireshark I have captured the link. Now I can see all the data on this link. This is one networking tool. Wireshark is a network tool which is used to capture the data. What is Wireshark?
Data.
A networking tool used to capture the data on link.
Yeah.
Very good. Now in the capturing I can see my data. Here you can see. Now if I will try to again send telnet data, telnet 10.1.1.2, you can see, are you able to see the TCP SYN message first? Then
TCP, yes, I can.
SYN plus, then SYN plus ACK, then ACK. And after that actual
Yeah.
TCP, actual telnet data. Am I right?
Mm-hmm.
So first machine has established the TCP connection before sending the actual data. After that there is actual data, actual telnet data. Similarly, if I am going to send the UDP based traffic, let's say I am saying config T interface F0/0 IP address DHCP.
This will use UDP, no?
UDP.
DH.
So you can see
Yeah.
sender machine is directly sending the discover message. There is no any TCP message.
SYN.
SYN
Yeah.
is
There
not
is no
there.
SYN. Yeah.
SYN is not there. This SYN is for telnet. Just to finish the
Yes.
connection, that is called fin bit on message. Once you will close the
Oh,
application TCP connection, it need to terminate the connection as well, right? Because server has limited, server can maintain limited number of connection at a time, right? So if
okay.
user has closed the application, they need to terminate the connection as well.
Mm. Yes.
So how it will terminate the connection? With the help of four messages, fin messages,
Oh, fin message.
right? Fin push acknowledgement. And see the discover message. Discover message is going directly because it is UDP based traffic. And if you want to see what are the information in UDP header, then here is your UDP header. You can see source port number is there, destination port number is there, length of data is there, checksum field is there, and payload is there, actual payload. That's it. If you will check the TCP header, let me open the SYN message.
Mm-hmm.
See what are the information inside TCP header. Source port again, destination port again. The new header, new
Sequence.
information is sequence number. Here you can see
Sequence. Yeah.
sequence number, acknowledgement number. These are not available in UDP. Am I right?
Yeah.
Window
Yeah.
size is there. Urgent pointer. You will learn about these all fields, but these are the extra information in TCP header.
Okay.
So in the UDP header, we have less information as compared to TCP header.
TCP.
That's why we are saying TCP is slow and UDP is fast. But TCP is more reliable than
UDP.
UDP. Now, this was the task of transport layer. Fine. Now my
Yeah.
transport layer is done. Now transport layer will forward the data as it is to the lower layer.
Network.
Yes, to the lower layer, to the network layer.
Network layer.
I will take example of any TCP based protocol, PC and server.
Okay.
server. Which server it is? It is, for an example, let me use my pen. That will be better. Yes. The client machine is sending, let's say, HTTP request. And you know HTTP
Mm-hmm.
request is TCP based. Application layer has generated this and now it will send to transport layer. Transport layer will do what? It will create one connection.
Mm-hmm. Yes.
TCP connection. And after TCP connection, it is going to forward the HTTP request to lower layer, to network layer. What network layer will do with HTTP request? And now in the HTTP request there is TCP header as well, right?
Yeah.
TCP header. And now network layer is going to add network layer header.
Okay. Network.
Network
Okay.
layer header. In the network layer header, see in the TCP header, what are the information? I can frame it like this.
The source IP, destination IP,
Yes, very good.
the
See, the
sequence.
actual data is their payload, and after that there will be transport layer header. Transport layer header. In transport layer header, there can be TCP or UDP header. Am I right?
Yes, sir.
Then there
Yeah.
will be network layer header. Then transport layer will forward it to network layer. Network layer header. In network layer header, again there can be IPv4 header or IPv6 header or any other protocol, IPX.
Mm-hmm.
Then network layer will forward it to lower layer, to data link layer. Data link layer will add data link header. Right? In the data link here layer header, we will have Ethernet header. Right? This is the complete packet. This message will be sent from PC to server. PC cannot send HTTP request directly to the server. Am I right?
Yeah.
And if this is a HTTP request message, then transport layer header will be what? TCP. Right? In the TCP, what will be the information in the TCP header? Source port, destination
Yeah.
port, sequence number,
Sequence.
acknowledgement,
Acknowledgement.
window size. We'll talk about the window size,
Um,
checksum, and many more.
yeah.
In the IPv4 header, what will be the information? Source
The IP
IP,
address.
destination IP, TTL, and some more field. In the Ethernet header, what will be the information? Source MAC, destination MAC, checksum, and some more information. Type field. So every layer is adding the extra information. Now, this is
Okay.
my PC. This PC has generated the data. At which layer? At application layer.
Application.
Right? Application layer will forward it to lower layer, to the transport layer.
Okay.
Transport layer. So at transport layer, we will have actual data plus
All these headers.
transport layer header. It can be TCP header or UDP header. Right? And
Yeah.
this particular thing is called segment. What we called it? Segment. Segment means what? My actual data payload plus transport layer header.
Mm-hmm.
And then segment will be sent to lower layer, to network layer. Network layer will receive the segment, and network layer is going to add segment plus network layer
Network
header.
header. Hmm.
It can be IPv4, IPv6, and this particular thing is called packet.
Okay.
Packet means segment, which is again the payload for network layer plus network layer header, and then network layer will forward it to lower layer, to data link layer. Data link layer will receive a packet, and it will add the data link layer header, and this particular thing is called frame. What we call frame.
O-
So see, at
Okay.
layer 2 we call data to frame, At layer 3 we call data to packet, at layer 4 we call data to segment, and at application layer we call data. Packet means
Okay.
segment plus payload plus header. Segment means payload plus header, transport layer header. Frame means payload plus data link layer header. This is the responsibility of your OSI model. Is it clear?
Yeah. So can you please go back? No, that. Yeah. Thank you. I'm just noting something quick.
I will send you the note study material, complete study material. Don't worry. Everything
Okay.
is mentioned in the note.
Okay. It's good. Thank you.
So OSI model is responsible to add these extra headers, establishing the TCP connection, right?
Yeah. Okay.
And adding extra information with actual data is called
Encapsulation.
encapsulation. And removing that extra information with actual data is called
De-encapsulation.
decapsulation, right? So if there are two PC2, this
Mm-hmm.
this is the sender machine
Yeah.
and this is the receiver machine. IP address 10.1, IP address 10.2. So which
Yeah.
machine will perform encapsulation if PC1 need to send some data to PC2?
PC1.
PC1 will perform encapsulation and PC2 will perform
Decapsulation.
decapsulation, right? The actual data is this one. The data, it can be anything. It can be mail data, web data, video, text, file,
Yeah.
or ICMP, OSPF, BGP, any data, doesn't matter. But with the
Mm-hmm.
data, it is going to add some header at transport layer. There will be
Yeah.
TCP or UDP. At network layer, there will be header like IPv4 or
IPv6.
6. At network layer, there will be Ethernet header.
Yeah.
Depending on my Ethernet media, there will be one header at data link layer. This particular thing is called encapsulation, right? And this is called frame, this is called packet, this is called segment. If I will talk about,
So one.
yeah, yeah.
Yeah. So one question. Sorry. But is you see by default you say Ethernet. It's a connection. If it is wireless, then what do you say then?
In case of wireless, we'll see what will be the information there, na? In the wireless. Don't worry. Try to understand our Ethernet media first. In the LAN,
Okay.
most popular technology is Ethernet. Now we are learning the Ethernet at layer 2.
Okay. Mm-hmm.
Okay. In case of wireless, there will be also header. And which header will be there? We'll see that what information will be there. So we'll discuss that also.
Okay.
Now PC1 will send it to PC2 and PC2 is going to receive what, guys? Bits. Bits at which layer? At physical layer. And physical layer will
Yes.
convert it into frame and then hand over to
Yeah.
layer 2, data link layer.
Packets.
Data link layer will receive frame. Inside the frame, there are two things, right? Packet,
Packet and the data link header. The
very
data
good.
header.
Packet plus data link layer header.
Mm-hmm.
So your data link layer is going to check this Ethernet header, not the packet. It will check this
Yeah.
header and then it will remove this header and hand over the packet to upper layer. Network
Yes.
layer. Network layer will receive the packet. Inside the packet, again, two things are there. Segment plus network layer
Network
header.
layer header.
Let's say IPv4 header. So network layer is going to check IPv4 header. It will remove the IPv4 header and hand over the segment to upper layer.
Transport.
Yes.
Yeah.
Transport layer will receive segment And inside the
Yeah.
segment, there are two things: actual data payload plus transport layer header. Now
Transport layer
transport layer is
header.
going to check this header, and in the transport layer header it will check the destination port number. If destination port is, let's say, 443, then it will check the port number 443 is enabled on me or not. If it is enabled, then accept it, remove it, and it will hand over the data to HTTP protocol. HTTP protocol will
Okay.
check it is request, then let me generate the reply, like that.
Wow. Okay.
Clear?
Yes. Yeah. Kind of. Yeah. Yes. Yes. Yeah.
Right.
It is.
So on the sender machine, that's why I said on the sender machine and receiver machine, application layer, presentation layer, session layer, transport layer, network layer, and data link layer, and then physical layer.
Yeah.
Sender machine, on the sender machine your data will travel from application to physical, and your receiver
Mm.
machine
Physical to application.
physical to application, right? So application layer can be layer 1 also, and it can be layer 7 also.
Okay.
If someone is saying application layer is
Okay.
which layer, you should ask on which device, sender device or receiver device.
Exactly. Yeah. Yeah.
Right? We cannot say it is
Okay.
layer 1 or layer 7 directly.
Yeah. Yeah. It's clear. Yeah.
What you can do, you can configure it in the packet tracer. You all have packet tracer?
I have on my PC. Yeah.
Yeah, so you can configure the lab in packet tracer, and you can test there in the TCP header and
Um.
these all things. In the next class, we will talk about the flow in detail. In more detail, we'll see the detailed information inside the headers.
Okay. The lab, you will assign a lab for that, or I
Yeah,
can
I am
just
going to assign the
what?
lab. Before next class, you need to check this. In the
Okay.
packet tracer, what you can do, you can connect to PC.
Mm-hmm. Okay.
PC1 and PC2. On PC number 2, you can enable any service. Telnet, HTTP. If you don't do the command, then you can ignore it for next 2 to 3 classes. After that, you will be mastered in basic commands. Because we will
Okay.
have one class for Cisco commands. There I will discuss all the basic commands. By the way, I think you guys have one note file. Let me show you that.
Okay.
Mm, 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 mm.
Yeah,
iOS.
you have shared many files. So, I have started with the basic networking.
Here it is. I'm
Um,
talking about this one. Here you will find all the basic commands.
so I can't really see quite well. It's a bit blurred.
The name of file is basic iOS commands.
Okay, basic iOS commands. Okay, I will look for it.
Right? So this is how you are accessing the devices. Then you will run the enable command. Then you will run the
Uh-huh.
configure terminal command. And after that, here are the configuration, basic configuration of router. Right? Like how to
Okay,
configure the host name. This is the command. How to configure the banner on router. This is the command. How to save the configuration. This is the command. How to configure the password. This is the command. How to enable secret password. This is the command. Verification command. Console password. Right?
okay. Yeah, the list is long. Yeah.
Now you need to go through two file. One is this one and one is this one. You already have both the file notes. One is this one. What is network? This one. In this
Mm-hmm.
one you will find the theory. Let me show you this as well.
Okay.
These two are the nodes for now. Yes, here you can see the same thing. Networking, we have already seen advantage. Types
Hmm.
of network, we have already seen. Components of network, we have already seen. Types of communication, we have already seen. Modes of
Yeah.
communication, we are already done. Networking devices, you can skip it for now, and you can directly jump here to the OSI model. Here
Okay.
we are done with the OSI model. We are done with these layers. Here are the detailed information about the application layer. Same thing which we have discussed in the class. That's why I told you don't need to write the note.
Mm-hmm.
Each layers are there. Then port number. Tomorrow we'll discuss about the port number. Here are some important networking
Okay.
application layer protocols. You can see which protocols is using TCP or UDP. Then transport layer. Transport layer provides reliable or unreliable delivery, perform error correction before transmit. Two protocols work at this layer, TCP and UDP. Here are the
Mm-hmm.
differences between TCP and UDP. The same difference which we have discussed: connection oriented, connectionless.
Yeah.
We can arrange the receiving data, reliable, three-way
So
handshake.
I have seen four handshake, four-way handshake.
Four-way handshake is used to terminate the connection. Like
Ah,
three-way
okay.
handshake is used to establish the connection. Four-way handshake is used to terminate the connection.
Okay. Mm-hmm.
You have seen na, in the telnet there was four messages at the last.
Yeah, yeah, I did notice the end session. Yeah, perhaps yes. Okay.
Here it is. See,
Since
before
in
discover message. 1, 2, 3, 4. One,
okay,
two,
okay,
three, 4. First message is fin message, then acknowledgement, then fin message from another device, and then acknowledgement.
okay.
Fin
Yeah.
means finish.
Mm-hmm. Yes, yes, correct.
Then connection oriented, three-way handshake, sequencing.
Oh,
So many things are
yes, yes.
there, right? Then network
Yeah.
layer, your data link layer, your physical layer, right? PDU means form of data at a particular layer, segment, packet, and frame, and then bits. What we call data at application layer, data only. At presentation
Mm.
layer also data, at session layer also data, but at transport layer we called it,
Segment,
at network layer we called it,
bucket,
at data link layer we call it
frame,
frame,
and then bits.
then bits.
Uh,
Then encapsulation, decapsulation. Encapsulation means adding extra information with actual data. Decapsulation means removing extra information with actual data. Because end-to-end communication, if I will talk about PC to PC communication, PC1 and PC2 need the actual data. Why we have added those all extra information? Just to send it to the correct destination. Am I right?
yeah.
So as a network engineer, you need to learn those extra information only. You will troubleshoot the network on the basis of that extra information only.
Mm-hmm. Yeah.
We don't need to do anything with actual data. That is the application. Am I right?
Yeah. Yeah.
But the transport layer information, network layer information, data link layer information, those are very important for us. I'm taking CCNA
Oh.
classes after 2 years.
Oh. Hmm.
TCP IP and then headers you can see. What will be the information inside TCP header? Source port, destination port, sequence number, acknowledgement, header length, reserve, flags, window size, checksum, and agent pointer for QS. We'll see these all filled one by one. Similarly, at in the UDP header, these are the information. See, you can compare TCP header and
Hmm.
UDP header.
Yeah. Yeah.
Right? Then IP header.
Very.
Yes. Any question?
No, no, no. It's fine. I'm saying a very less information in UDP header compared to
Correct.
TCP.
Correct. Correct. Then IP header and Finally, segmentation, fragmentation, and then we'll talk about all the application layer protocols, important application layer protocols, one by one. HTTP, HTTPS, Telnet, SSH, FTP, TFTP, NTP, DSCP, DNS, and then next topic, IP addressing. Right? So download these two files in your system, in your laptop today, and start going through it.
Yeah. Yeah, sure. Yeah.
Right? You also need the
Yeah, for the
GNS3,
lab.
GNS3 and packet tracer. If you don't have GNS3 and packet tracer, you can ask for help to set up it. Otherwise, it's easy. You can find video on my channel to set up the lab.
So bucket tracer I have already. So you said one more GNS3.
Yes, GNS3.
Okay.
And you will find one video on the channel to set up the GNS. Like all the images are there in the description. Let me show you.
GNS3. Okay.
GNS3 PM networking.
Okay, so you're going to
Here it
share the
is.
lab for to work on packet tracer already. You will share it.
Yeah, but later we'll use GNS3 as well. You can
Okay.
go through this video to set up the GNS3. Otherwise, it's easy. You can do it by yourself as well. I am putting the link over
Cisco.
here in your group.
Okay, yeah, yeah. Thank you so much. I will do it.
I'm putting the GNS3 link in your group CCNA June.
Yeah.
Here it is. Anything else?
No, no, sir. It's fine from my side. So we see you tomorrow then.